Okay, guys, we're recording. Thanks. Appreciate it. Okay, so we're going to do the first 3 pages of these notes. Once I get these first 3 pages done, you guys can get head start on the homework. Homework, I'm only going to probably just assign like maybe 6 problems. Keep it really short. That way, if you want to watch a Thursday night football game, Chargers and Chiefs, or some free time during the weekend to watch Stanford lose again, or
I very much appreciate that.
or you know, watch the Niners on Sunday afternoon. I don't know. So anyway, so we should have enough time to get homework done as well. So let's get these notes so let's not waste time. So y equals x squared. I know I heard some mumbles and some groaning, like, oh, like, you know, like, oh, we're doing this x squared stuff. It's not that hard, but we're going to start pretty easy. So you're squaring x, right? So quadratic functions is basically when you have an expression with x squared. That's what a quadratic function is. Oh, sorry.
Oh, an expression with
X squared, exactly. So an algebraic expression with x squared in it. We will do stuff that's higher, like x cubed and x4. That won't happen until after we finish chapter 4, probably not until after Thanksgiving or right before Thanksgiving. But for now, we're just going to focus on quadratic functions. And the most basic quadratic function is y equals x squared. And you guys should know what happens when you square something. You just multiply it by itself, right? Like, for example, if I have -3 squared, in parentheses, I'll put -3. That obviously implies to multiply -3 by itself, which of course is what? 9, right? And the output's always going to be positive unless you plug in 0. Unless you plug in 0. For y equals x squared, the output's always going to be positive unless you plug in 0 for x. So like that's 9, 4, 1, 0. And then it repeats. 1. Nope. Nor is it negative. Just, it's in limbo. It's torn.
So that's the parent.
Yes, it's the most basic. The parent function.
Pretty basic stuff.
It is very exactly what I was saying. It's not that hard. It's the most basic function you could think of when you call a parent function. Now, if you plot the points, not hard. 0, 0, 1, 1, 2, 4, 3, 9. And then you have this on the other side as well. And by the way, do you guys see the symmetry? Do you guys see the symmetry that's happening here?
Amazing.
Wow, so
Yes, exactly. So there's an axis of symmetry. So x equals 0 is called the axis of symmetry. We're going to use that term a lot. And it just means it cuts it in half, right? Axis of symmetry, right here. So it divides a parabola into 2 pieces. We call these parabolas. And there's actually a deeper meaning why it's called a parabola, which we'll get to that in the second semester if we have time to get to that. But yeah, it's just mirror images of one another when you divide into 2 pieces. So on the parent function x symmetry is the line x equals 0 or the y-axis. Or just the y-axis, right? The vertex is the low point or the high point. So I call this the vertex. And what are the coordinates there? 0, 0. So for the parent function, the vertex will get 0, 0. So it can either be the lowest or highest point depending on how it opens. So again, this stuff should be kind of review, should be very basic. We're going to start shifting things around just a little bit. Any questions so far? Okay, kind of clear? Cool, it's clear. Okay, so again, 0, 0, that's the course of the vertex. And the axis of symmetry will always pass through the vertex. Well, let's look at another one. What do you think is going to happen for the second example now?
It's going to be double.
What's double? The what? Yeah, it gets skinnier. So basically, it gets more steep, or the y value is double. The y value is double because now y is twice what it was before, right? So what's going to happen? Vertical stretch, the y coordinates will double. Or a graph gets more steep. So this is the parent right here. And this is the new graph right here. Actually, let me change colors. So this right here is the parent,
The X or the X?
the x squared. And that's the new. So we already know this 4, 1, 0, 1, 4. But the new graph will be 8, 2, 0, 2, 8. Do you see how the y coordinates got doubled? As they should. We multiply by 2. So when you do the new graph, it looks like this. Yeah, 1, 2.
Is it, do you do the 4 and the?
2, 8. No, we're graphing these.
Oh,
We're graphing these right there. Yeah, so I'm not going to do the parent. I'm just going to do the new one on here. Oh yeah, Patrick, go ahead.
What's it called when you like the growth, like the 0 to 2 to 8? Like what's that called? Since
It's not slope.
you mentioned
It's not.
it wasn't called slope. So it's just called like.
It's not really called. I mean, we could say that the graph's getting stretched as a result, but I don't know if it's really called. Yeah, I mean.
I didn't know if it was like a vocabulary.
No, it's not. No. So vertex is still 0, 0. That didn't change. Axis symmetry is still x equals 0. That didn't change. Or the y-axis. So none of that changed, right?
why is mine getting wider?
What do you mean by wider?
Look, it's
Oh, did you do 4, 8 and 1, 2? You probably did. Yeah.
what? Wait, which one?
Why is it negative 2?
You're doing 1, 2. Yeah, 2 and 8. Yeah, 2, 8. And then negative 2, 8. 1, 2. Yeah, she gets skinnier. Gets skinnier. Yeah, gets skinnier.
Oh,
Yeah, you're fine. Yeah. By the way, you can also go to Desmos. If you go to Desmos and like do y equals x squared, you have that. If you have y equals 2x squared, see how it gets skinnier? And I'm going to go and clear my screen. Or if I make that 4x squared, gets even skinnier, or 8x squared, gets even skinnier. But if you do 1/2 x squared, it gets wider, exactly.
oh.
That's because you multiply y by the y coordinates get smaller. Because now you're taking half of the y coordinates from previous.
Oh, so there's like 4, the 4 becomes 2.
Right. Okay, let's look at another one here. What if I put a negative out in front? So in this case, and by the way, the one thing I forgot to mention, we call this the leading. Okay. Now, some terminology. So actually, Patrick, to answer your question about terminology, I guess you can say the leading coefficient impacts what you were talking about, like those y coordinates that can get more steep. The leading coefficient is responsible for that. So the leading coefficient is the number in front of x squared. Now, if a were to equal -1, how do you think the graph would change?
Then it's x negative. Then it'd be going.
It'd be positive X.
Oh,
No, if the leading term is negative. So if you have y equals -1,
it'd be like down.
what makes what negative?
It'd be going down.
The y coordinates. And so the graph, what happens to the graph? It goes down, exactly, right? Right, exactly. It's PEMDAS, right? You do the exponent first and negative afterwards, right? Now, the parent function again is this: 9, 4, 1, 0, 1, 4, 9. But the new function is going to be this: -9, -4, -1, 0, -1, -4, -9.
Because it's like negative.
Exactly, right. So PEMDAS, guys. Exponent, then multiplied by 1. Sorry, by -1. My bad. Exponent, then multiplied by -1. So in this case, I have 0, 0. We'll change colors. So 0, 0, 1, -1, 2, -4, and 3, -9.
It's upside down.
Totally.
So simple.
And the graph is just that. Axis symmetry is still the same, vertex still the same, because it did not move the graph horizontally. Yep. Okay.
Would you have to write x equals 0 y axis?
No.
It's
It's your call.
Wait, so they're all x equals 0 for the symmetry?
Now it'll change for number 4.
Oh.
Okay.
Oh,
So
it's gonna be like 4x.
so far we're okay.
Oh, wait,
We're good?
Oh, it's the same. It's the same as if
Okay.
we're doing this, but with like the absolute values, right?
Yeah, exactly. Yes, this is totally analogous to absolute. That's a great observation, Hugo. This is totally analogous to absolute value. Yeah, go ahead. So let's talk about this one here. So here's a couple things happening. And actually, this table is being weird. I don't know. That's a typo. That should be. Yeah, that table's. I don't know why it says. I don't know why the last column said negative x squared. It doesn't make any sense. Before I do this one, let's go to Desmos. Okay, Desmos is our friend. All right, what if I put a +1?
And starts higher because that's the y.
Yeah, and actually, let me change my my grids here. This is set for trig. Negative 10, 10, 1. There we go. Yeah, you can see that the graph shifts up by 1 unit. Or if I do 2 units, right? -1 goes down 1, -2 goes down 2, and so forth. Now, what if I had this here? Come on.
You do minus the x, and it goes to.
Now, we talked about this with absolute value. It seems counterintuitive. When you do x -1, it shifts 1 right.
Okay,
If-
so, like, let's say we knew what x was, like, if x was 2, we wouldn't do 2 minus 1 and then.
Squared, yes, exactly.
Do what?
You would, because PEMDAS. Take care of it inside the parentheses first, right?
Yeah.
But a +1, it's just 1 left. Also, it seems a bit counterintuitive because you think, and while actually you guys can spot whatever you guys are doing. Thanks. Awesome. +1 means shift 1 left. Or if I do +2, 2 left. Or +3, 3 left. +4, and so forth. So generally speaking, we could think of this as y equals x minus h squared plus k, where h is the horizontal. H is actually the x-coordinate of the vertex. That's one way you could think of it.
Oh, the vertex just whatever.
And k is the y-coordinate of the vertex.
Okay.
So going back to the example, this one, again, this is going to be that right there. So first off, actually, I don't like the way this is set up. This table is actually set up pretty terribly. We know this is true, right? 9, 4, 1, 0, 1, 4, 9. Okay.
You have to like
Yeah, that
adapt
is
it to the x or to the y.
Okay. What was that? Sorry?
No, wait, for that, would you have the table, or could you just do like, you know, to the right or off?
Yeah. Well, I'm gonna make a new table actually. Here's what I'm gonna do. I'm gonna do a new table. So this is the parent. This is the new. Okay. So what do we do here? H is 3. K is -5. So what you're going to do is you're going to add 3 to x. And here, you're going to subtract y by 5. That's what we're going to do. You're going to add 3 to x, subtract y by 5. So if I add 3 to x, that's now going to become 0, 1, 2, hold on,
0, 1, 2,
3. Sorry, I'm just going blank.
2, 3.
Yeah, actually, let me line it up better. Give me a sec. Sorry, guys. Let me just line it up better. Let me extend it this like this.
So when it's -5, that changes the vertex.
Yes. Yes. Okay, this is a new one. So now what you're gonna do is you're gonna do this. Let's go blue. So you can have, if you add 3 to x, you get 0, 1, 2, 3, 4, 5, 6. And if you subtract y by 5, you're gonna have 4, -1, -4, -5, and then -4, -1, and 4.
Wait, so you subtract it from the original one? not-
Right, from the original one, yes. So what I did was I subtracted y by 5 and I added 3 to x. So now these were the original y values right here.
Oh, he, one of the coordinates is.
3, -5. Oh, I took these x's
That's our vertex.
and I added 3 to them.
Okay.
It's X-
And the reason why is because h is 3. Because the formula is this, y equals,
Even though it says
h is a
negative-
x coordinate of the vertex.
Okay.
Even though it's -3.
Or the horizontal
you still
shift.
Add it by 3. Because it's like opposites.
Yeah, x minus 3, right? Because you assume x minus h, right? Exactly. So you have 0, 4, 1, -1. Wait,
You Add 5.
sorry, hold on, I messed
so
up.
you subtract.
0, 4. Sorry, I did 3, -5 first. Let's just go in order. Sorry, 0, 4, 1, -1, 2, -4, 3, -5. Then I have 4, -4, 5, -1, and 6, 4. There we go.
Wait, so, oh my god, okay. And then,
So you see how this is transformed, right? We took the original coordinates from over here. And because of x minus 3, I had to go 3 right. That's why I added 3 to the x coordinates. So Elizabeth, to answer your question, how did I get these new x coordinates? I added 3 to these guys
Okay.
to get these. How did I get the new y coordinates? The -5 on the outside. I took 5 away from what you see in green. That's now in blue. So I added 3 to get this. I subtracted 5 to get this. This table off to the right is the transformed coordinates for the new graph, which looks like this.
So, oh, wait, never mind.
Once you get very good with this, you kind of know to take the original points and shift them up, down, left, right, depending on what h and k are. But you have to identify what h and k are before you get too carried away. And how you identify h and k, compare it to this formula right here.
so the vertex is 5.
The vertex is 3, -5. And the axis of symmetry is going to be x equals 3.
X.
Yes.
I was
Good,
confused
good, good.
at first, like,
Is this the same logic if it's like 2x, 3x, 4x, 5x? The same logic?
Yeah, if you have a number being multiplied, then you're going to multiply the y coordinates by that number.
Okay.
Yes, of course, absolutely. Okay. So, and don't worry, we're doing this again on Monday. It's not like, yeah, go ahead, Matthew. It's not like, okay, we've done this, we're going to leave this station and never come back to it. We're going to do more graphing on Monday and Wednesday. So don't worry, we're just introducing it right now. We're going to spend a lot of time with the stuff. Let's keep moving to these guys. So here you're asked to describe. Now, remember you guys had a hard time with that in our first test. Let me show you how I want you to describe it. What I want you to do is identify A, H, and K. Okay, I want you to identify those 3 things. And generally speaking, this is what we have for a parabola or a quadratic function. Okay. A, H, and K. Now A, this is a text box.
wait, so why? Wait, what is this for number 5?
Describing the transformations.
Y equals,
A parentheses x minus h squared plus k.
and H is horizontally and
Mhm,
K.
mhm. So I'm gonna put a little text box here. A is for vertical stretch and reflection about x-axis. H is for horizontal shift. K is for vertical shift. This will be true for every single function you see in your life. In this class, pre-calculus, calculus, beyond calculus, this is always true. Here we go. Actually, let me move it. Let me shift it to an area where it's easier to see. Here we go. So A is always for vertical stretch and reflection about x-axis. H is horizontal shift, K is vertical shift. This is always true. When you do trig, I'm doing trig with my pre-calculus students, I lean back to this. For those who are doing PSAT next month, they do actually use this kind of notation. And so you'll have to get used to it when you start doing test prep for STAT in the next year or two. So these are just very common things you see. Now, when you're asked to describe, you have to kind of go through this list here. If you see A, if you see an A value, you tell me A is this, it's stretching the graph by this much. If you see an H value, okay, H is this, it's moving the graph like this. If you see a K value, K is this, it moves the graph like this. So let me do part A with you guys, just so you can see what I'm looking for. So here's how I want you to write it. And I didn't really do this that well with absolute value because I was kind of thrown into a loop because I didn't think it was going to be in those notes. But I did definitely anticipate for this one. So here's what I want you to say. I want you to say this. Compared to y equals x squared. Yep. The new graph will be transformed in the following manner. Is this someone outside on a like loudspeaker? Okay, sorry, just a little distracted. Okay, here's what I want you to say. Shift graph 5 left. I'll explain. Reflect about x-axis. Someone's like sounds really mad. What's going on? Oh, sorry. Go ahead.
Would you equal A, like in this, like there was gonna be x-axis is what A is.
A is -1 here. And then let me add this as well. Give me 1 sec. Let me add this. This will help. This will answer your question.
Like I thought one was gonna be what A is, and then 2 is.
Oh no.
That's why
Yeah, actually, I should reverse that. Actually, give me 1 sec.
Wait, so could you ever have a problem that's like a C shape, like it goes along the X inside of the Y?
Yes, but we're not going to cover that.
You have to write reflect about x-axis, or could you write like flipped?
No, reflect. We're gonna be proper.
And what if it's like -2 as A? Then how would you say reflect about x-axis and stretch by 1?
Exactly. Right. Okay. So let me clarify because I kind of confused you guys a little bit. Okay. I much prefer you state the horizontal shift first. Here's the reason why. PEMDAS. When you look at the equation here, if you're pulling number for x, what's the first thing x sees? Does x see the exponent first? Does it see the -4 first? Does it see that negative on the outside first? Or see the +5 first? What's the first thing? The +5. The first thing x would ever see when you plug in a number for x is see that +5. That +5 is responsible for shifting the graph horizontally. Right? We've seen that already. So I want you to state that first. Then after you square it, after you add the 5 to square it, what's the next thing we do? We multiply by -1. Then that -1 on the outside, that's A. That's responsible for reflecting the graph out the x-axis. I want you to say that second. The last thing that happens is a -4 on the outside. That's responsible for moving the graph up or down. Why go ahead? Oh, sure, yeah, go ahead. Yeah. That's responsible for moving the graph up and down. I want you to say that last. So I am going to be very nitpicky about this because I want you guys to be successful in your future classes. Because especially when you move on to calculus, you really have to be proper. Otherwise, your graphs are going to be way off. Your answers are going to be way off. You really have to follow the order of operations. It's so essential. So this really follows. So the order matters.
Is that
Yes.
a test question?
Yes, I think this will be a test question. Absolutely, 100%. So PEMDAS, order matters, and it's basically H, A, K. Because it sees H first, it sees A second, it sees K third. So yes, the order does matter.
Can you go over B?
We're gonna do B next. Okay, Patrick, good.
So in the green text, is that how you want us to answer a question on?
100%, 100%. Yes, that's exactly how I want you to answer it.
Does it matter what you say first?
Yes, you gotta see the horizontal shift first.
Okay.
Absolutely. Yep.
I know you just said that.
No, no worries. That's
Is there any way to undo what you just did so we can see that thing is really good?
why not. This is the beauty about Zoom.
Wait,
This is why I like to describe Zoom because I could do that.
wait,
I
okay.
can,
I don't know, like, when you-
and this is recorded too, so you guys could watch this later if you like. Yes.
It has to be whatever was first in line.
Exactly. Basically, what's the first thing X would see? If you were to plug a number for X, it would see the it would see the plus 5 first. Because PEMDAS, right?
That's how you write it.
100%. 100% that's how you write it. Okay, let me go and clear. So let's look at part B now. So A is 1/2. H is 0. There's no H. And K is 7. So we don't have to worry about horizontal shift. So here's what I would say. I would say vertical stretch.
You have to say vertical.
Yep. And shift
Oh my god.
7 up. I didn't have an H. Didn't have to worry about it. Didn't move left to right. But 7 up because it's plus 7.
So wait, why didn't you have the other one that were functional?
There's no negative out front.
Oh.
There's no negative out front. That's why. If you have negative out front, you do. You're all done?
Yeah.
Wow, you're fast.
4 people did not.
Oh,
get
wait,
the
it's,
B.
I thought it was.
That's fine. Yeah, so if you have extra time, if you're taking extra time, that's fine. I'm usually in the math office. If you're trying to come find me, that's the little like room over there. Or you can email me. And
Cool.
Thank
It's
you.
already graded?
Yeah.
Can I check?
Up to him.
Okay. So let's finish off this last page of notes, and then we're done for today. All right. So let's try another one here. Okay. So here's what you want to do. For the parent function, this is y equals x squared. We know if we plug in -2, I get 4, 1, 0, 1, 4, right? We know that. Okay. Now let's look at what A, H, and K are. A is -1, H is -5, and K is -4. Remember, generally speaking, the formula is this: y equals A, x minus h squared plus k.
So you flip the sign for the eight.
For the what, sorry?
You always.
Yes, right, exactly.
Usually it's negative outside the.
Right, right.
But if there wasn't a negative
Mhm.
outside.
I think that'd be weird.
Okay, let's start with x. Let's get the new x here. Okay, we're gonna shift 5 left. So what this means is you have to subtract x by 5.
Four minus five.
So what I just do, guys, I took the x size and took away 5. Why did I take away 5 from here? Because yep, yep, h is -5, right? H is -5. That's what happens. We shift 5 left. Now the y coordinates. Here's what happens to the y coordinates. So if you multiply the y coordinates by -1, you get -4, -1, 0, -1, and -4. So what I'm doing here is I'm multiplying y by -1. Then subtract y by -4 from this column. When I say this column, I'm referring to that. So you take 4 away from this third column, if you want to call it that. So that's me -8, -5, -4, -5, and -8. And this right here the new coordinates or new points. So what I've done is I've transformed, and this right here is the parent. Which is y equals x squared. That's an arrow. That's a terrible looking arrow. Yeah, so that's y equals x squared. So that's the parent function. What I did is I took 5 away from x, and then for y, it had 2 things, right? A and k impact y. A and k impact y. A is -1, multiply y by -1. K is -4, take away 4 after you multiply by a. So what you do is that h, I'll write on the board actually. That's not one thing in the video, but because everyone's here. So h impacts x only. A and k impact y. Do A first, then K. You do the A first because of PEMDAS, right? And A means multiply, K means add or subtract. This is the way I want you guys going about graphing with transformations. It's a different way of thinking. It'll take some time to get used to it, and we'll spend more time Monday, don't worry, more time Wednesday. But I don't want you guys getting so used to just like plugging random numbers in, because that's not a very efficient technique. We want to get better because we're going to do logs, as Hugo was talking about logs about half hour ago. It's a weird kind of function. We're going to talk about radical graphs. We're going to talk about polynomial graphs. We're going to talk about exponential graphs. We're going to do rational functions. We do so many types of functions, and we have to understand how to transform it. And trig, you'll do trig next year. Okay, so now let me plot the points. And it's oh, no, I don't want to do that. Okay, I'm gonna have to do a little shift. Man, I didn't do what I wanted. Okay, here we go. Hold on. Give me 1 sec here, guys. Sorry. Yeah, I'll show you how. It's really easy. Okay, let's do this again. Ah, so much better. Okay, so let's plot this. So this will be y equals x squared over here. This will be y equals negative x. I need more space. This will be y equals negative x. Was it x plus 4? I forgot. What was the equation again? Plus 5. Thanks, Sally. X plus 5 squared. Guys, quiet, please. Okay, so here we go. Let's graph it. So 0, 0, 1, 1, 2, 4, negative 1, 1, negative 2, 4. So this is the parent function. That's yeah, we're gonna do the parent on the left and the transformed on the right.
Second graph or
Is there a part B? Oh, there is? Oh, that's for the table. Oh, well, you know what? I don't care. Actually, yes, AJ, you're probably right. Let's not worry about it. Because I think you guys are getting the point. Let's not worry about it. What does what say? Oh, yeah? Okay. I probably don't need a parent.
Parent? Okay,
Yeah. Multiply y by negative 1. Okay, no problem. All right, let's do the next one. Yes, Patrick, go ahead. Sure, yeah, go for it. No problem. So negative 7, negative 8. Negative 6, negative 5. Guys, quiet in the back, please. Thank you. Negative 5, negative 4. Negative 4, negative 5, which is my no, negative 5, negative 4. So negative 4, negative 5 is down here. Then negative 3, negative 8 is down here. Notice I'm doing 5 points, right? I'm doing vertex, 2 to the left and 2 to the right. That's usually what you want to do, 5 points. Okay, that was awful. I could do so much better than that. Okay, kind of better. So that's your new graph now. So everything got shifted and got flipped over. So
Well, we have to like look at it like 2 different things and then say which one got shifted.
totally. That's what we're spending all next week on this stuff. Okay. Questions on this one? 1, 2, 3, 4. Okay, I'm going to briefly talk about the next one and then stop because you guys have had a long day. I get it. Okay, can I clear? I'll wait. Yeah, so lastly for this one, that's a V, by the way. Okay. So that's the parent. And let's just kind of cross this off. Yeah, let's just do a new table here. Okay, here's the deal. H is 0. So X does not change. So X does not change. It'll still be negative 2, still be negative 1, still be 0, still be 1, still be 2. X does not change. It is nice. Now, A is 1/2 and K is 7. So what I'm going to do is multiply Y by 1/2. Then, I emphasize the word then, add 7 to y. So if I multiply 4 by 1/2, what do you get?
2.
And then add 7.
9.
Great. Multiply 1 by 1/2 and add 7.
0.5.
7.5. 0. Multiply 0 by 1/2 and add 7. 1. Multiply 1 by 1/2, add 7. And then last you get 9. I trust you guys can plot points. We won't need to plot it. I trust you guys can do that. But these would be the new points based upon what you see in the equation. So these are things we're going to work on. Now for homework, I'm going to give you guys a packet right now. It's just going to be 6 problems. No, we have homework. Okay, nice try. Hold on, let me find the right place. I'll give you guys a packet in just a sec.
My aunt's like, it's my cousin.
I think she record. I'm pretty sure she record. Actually, it's a great question. I don't know. Actually, I'm pretty sure she recorded it.
Yeah.
Yeah, why not? Sure. Okay. Okay. Anyway, I'm just giving you guys 4 prompts for homework. Everyone but Matthew gets one.
Sorry.
And let me stop recording, by the way. I don't know why I'm still recording.
I wanted to be a control, but I wouldn't like break the end.